Now we're going to learn a very important statistical concept. I think that if I say that will be the most important one, okay? It's called let me change it again. Probability distribution. We are going to learn what is a probability distribution. Of course, we're going to learn multiple. So we have an S here, probability distributions. What is a probability distribution? After this video, you should be able to identify a probability distribution. All right, now, first of all, we're going to talk about a random variable. Random variable. Random variable. And you learned in other math class what it is a variable, right? We use a letter to show it. Usually we use x. And here we also use x. And a random variable is a variable that has a single numerical value. So that has a single numerical. That's the most important one, okay? Numerical value. All right. And it's determined by chance, and then for each outcome of a procedure. So like for each test or for each time you observe something or something, we call that a procedure. And for that procedure, there is a outcome, and that is happened by chance. That's basically it says. It's kind of a complicated sounds, but the numerical variable, we usually call that x. All right, now the probability distribution is for each given value, for each value of this random variable, and there is a probability of it. All right, so that gives the probability to each value of the random variable. Now for this kind of random variable, there could be okay, number one, the most important one, it has to be numbers. Okay, it has to be a number. So even when you flip a coin, you get the head or tail, right? And that observation or that outcome, you cannot call that random variable because it's not a numerical, right? Numerical got to be a 1 or 0 or something like that, but it's not head and tail. Now, what could be the random variable? Let me see. If you toss a fair coin five times, okay, and then how many heads you're gonna have? How many heads you're gonna have? So that x, you use x to represent the number of heads of those five tosses. So that could be 0, could be 1, could be 2, could be 5, right? 0, 1, 2, 3, 4, 5. And for each of them, you have the probability of 0, which means you toss 5 times. And what is the probability that no head? What is the probability there's 1 head? And what is the probability there are 5 heads? And the number of heads that count, it's a numerical value. And then that's all the possible outcome. And here's the probabilities. We learned how to calculate the probabilities, right? So you can figure out for a fair coin, head and tail both have 1/2 of the chance to occur. So what is the probability of 0? Which means what is the probability there's no head? All 5 are tails. These are 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which is 1/32, right? Okay, so then that is the random variable and its probability. All right, so that's a general idea of it. And for this values 0, 1, 2, 3, 4, 5, did you notice that if you plot them on the number line, here's 0, here's x, the x-axis, if you plot all the possible values, you get a 0, 1, 2, 3, 4, 5, right? You get this 6 points on the number line. And because they're like isolated points, If you plot all the possible values on the number line and you get those single points, isolated points, then we call this as variable. There's a term for it. We call that a discrete random variable. Discrete, because they're not connected. Discrete random variable. All right. So what is the opposite of it? What is the opposite of a discrete random variable? The other one is called a continuous. Continuous random variable. So this two, just like a pair. Okay. And the continuous random variable means if you show me all the possible values on the number line, then you get an interval. For example, let's say height in inches. Okay, and then height in inches, and here's the other very far away is 0. So when we talk about all the students in a college, then maybe the tallest one, let's see, 7 feet, so that's 84. So here's 84, and then the shortest one, let's see, for 4. I don't know. I just made this up. Okay, so it's a 48, and any number between this two numbers, 48 and 84, any number is possible. Any value is possible. So if you plot all the possible values on the number line, you get an interval, and you get a continuous segment. So the height is a continuous random variable. Usually the count is a discrete random variable. Okay? So you get first off, we have this general idea. Now we are going to really go talk about a probability. Probability distribution, there are 3 requirements. 3 requirements. Okay. Number 1, X is numerical. Numerical. X is numerical, and the P of X is its probability. That's a first requirement. Number 2, the sum of all the probability equals 1. What does that mean? That means if you take all the X values in your possible space, and then the P of X, you add up to 1. All right, it cannot be more than 1, cannot be less than 1, has to be exactly 1. The third one, all the probability, every single one, has to be between 0 and 1. They're all positive, or 0 or positive, but they got to be less than 1. So those are the 3 most important probability. All right, and once you know that, then there are 2 more things, actually 3 more things I want to tell you, but we're going to learn this later. So number 1 is the mean. I just write it here, and then I'm going to give you an example later. The mean, mu, is the probability of X multiplied by X. Now you see why we really want this X to be numerical, right? Because if it's like a boy, girl, head, tail, then it doesn't have a value. How can you multiply? How can you do the multiplication for that? Okay, and then after you do this, you just add them up. Add all those products up. So that's your expected value. I'm going to explain this later, but now so far we just remember that. Okay, variance. For distribution, we have a variance, and that's a sigma square, and which is, sigma square is this. You use each X minus mu. That's what we just found out here. X minus mu, and then we square it, and then we multiply by the probability of X. Okay, after you do this, you add them up. So you add all those products up. Okay, I just write this bracket, but you don't really need to. All right, now after you get this variance, of course you would know the standard deviation. The standard deviation, you should be very familiar with that, right? Standard deviation is the square root of the variance, which is square root of sigma square. So if you figure out a sigma square, and then you just take the square root of it, and that is sigma. That's the population standard deviation. Okay, so it seems like I give you a lot of concepts, but don't worry, and you might get confused already, but don't worry, we're going to go over them using examples. All right, now first of all, first example, if you count the number of boys in a family with 2 children. Okay, we're doing counting, right? We count the number of boys in a family with 2 children. We count number of boys. If a family has 2 children, so how many boys are possible? Could be 0, could be 1, could be 2, right? Now, first question. What is the random variable? What is the random variable? Your answer is X is the number of boys in a family with 2 children. X can be 0, 1, 2. Okay, let's say or. All right, so that's your answer. That's your answer. What is the random variable? Random variable X is the count, or is the number of boys in this family with 2 children. And the value of that X can be 0, 1, 2. Is that numerical? Yes, 0, 1, 2, right? Okay, second question. What is the probability? What is the probability distribution of this variable? I just didn't say X, but it's X. So what is this probability distribution of this variable? What we're looking for is for each X, we look for what is the probability of X, isn't it? Okay, so X could be 0, 1, 2. 2 kids, 2 children. So could be boy and a girl for the first one. Could be boy and a girl for the second one, right? Okay. And for each of them, boys and girls are equally likely. But actually, it's not. I think boys has a slight, like 51% or 52%. But we just assume this is a 50%. Here it's a boy and a boy, so it's 1/2. This chance is, or we say 0.25. It doesn't matter. You can use this. A girl, this one also has a 0.25, and this one has a 0.25. This one, girl, 0.25. Now, let's see, what is the probability that there are no boys? Which is this one, right? No boy at all. Probability is just 0.25. And what probability that this family has one boy? See, this is the situation. That has one boy. The older one is a boy, younger one is a girl, or the first and then boy. So this two six. That's when X equals 1. You add this two probability up, you get a 0.5 or 0.50. Doesn't matter. What is the probability that x equals 2? What is the probability if you translate English will be what is the probability that there are two in this family with 2 children? So that will be boy, that is 0.25. All right, now we identify the x value and also we find the probability of each of them. Now let's see, can we determine whether the probability distribution. Do you remember what are the 3 requirements for the probability? Number 1, x is numerical. See, and p of x is p of x. Yes. So the first requirement, we're good. The second one, all the probabilities add up to 1. Let's check. 0.2 plus 0.5, which is 5, plus 0.25. So the summation of that is 1. Right? And then the third condition is every single probability values has to be 1. We check. No negative, and greater than 1, we're happy. So we're happy with the third requirements. So far this is probability distribution. All right? And the third part of this is x discrete or continuous? Discrete or continuous. Okay. The x values could be just a 0 and a 1 and a 2. If you plot that on the number line, you get a 3 dots. So the answer is discrete. That's your answer. Now you get some understanding about this probability distribution. All right. So let's see. Can we do this? What about a family? This is separate. Okay. You can work on this. Let's work on this quickly. What about a family with 3 children? Family with 3 children. So I'm gonna do this. Boy, girl, boy, girl, boy, girl, boy, girl, boy, girl, boy, girl. That's all the 8 possibilities. So we have a boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and a girl, girl, girl. Each of them have a 1/8 of the chance. Now, what is the probability distribution? The probability number of boys. That is our random variable. So x and the p of x. Let me see. For a family with 3 children, how many boys could be? Could be 0, could be 1, could be 2, could be 3, isn't it? Right? So that's all the possible values for x. And then what is the probability that there are no boys? This is only 1. Okay, so this is the only chance, or only 1/8, 1/8. Or if you want, you can write a 0.125. And that is the probability that there are no boys. And what is the probability that there is 1 boy? Let's see which one has 1 boy. This one, and this one. So 3 of them. So that's a 3 out of 8, which is a 0.375. All right, now what is the probability that this family has 2 boys? So that's this one, this one, this one. That's it. So that's a 3/8 again. It's 0.375. And what is the probability that they have 3 boys? And this is the only situation here. So that's 1/8 or 0.125. All right. Is this a probability distribution? Number 1, x is a random variable and x is numerical. It's right? We have 0, 1, 2, 3. And then p of x is the probability associated with this x. So number 1 requirement was good. Number 2, all the probabilities add up to 1. And if you add them up, and it is 1, because see, that's 1/8, 3/8, 3/8, 1/8. Of course, add up to 8/8 is 1. Or you just add all those decimal forms, then you're going to see that it's 1 too. That is 1. All right, so the third one, every probability value here is between 0 and 1 inclusive. There's nothing more than 1. There's nothing negative. So all the 3 requirements are good. So this is a probability distribution. It's just a quick expansion of what we learned. So now you get a better understanding, right, about what is the probability distribution and what is the requirement of it and things like that. All right, now let me ask you the next question. Example 2. Okay, we measure the height. We measure the height of the student in a school, and we're going to write it down. So number 1 student walking the school, I just let him stand there and then measure and then write it down. And then write down that in inches. Now, what is the random variable? Height of students. Height of students. So that is the random variable, right? So this random variable is height. Usually we do that. Comes with a unit, so we say in inches. Or it can be in centimeter, could be in meter. Okay. All right. Now x is a height. Then that is a random variable. Now, what is the probability of this random variable? Wait a second. What is the probability of the random variable? Inches, remember that we have all the heights between 48 and 84 in some school, and we have this information. So anywhere the height x between 48 and 84, any value is possible. So how do you find the probability? I tell you what, the probability goes up like this. It's like a bell curve. Most likely it's like the bell curve. Okay. We're expecting a bell-shaped distribution because here could be like a 65. I just think. So a lot of people's height around it, and the height shows the probability, and the area under the curve showed the probability. Remember, we have the old one. The old example, we have a 0 and a 1 and a 2. So we have a probability, right? So we have some probability like this. Remember the boy girl? So it's a 1/4, 1/4, 1/2, and a 1/4. So that's a probability. So we can have just a vertical line to show it. However, here we cannot find what is the probability that somebody's height is exactly 65. So what does that mean? That means if a variable is a continuous variable, you're not going to find the probability that x equals exact value. All right? So that's a very important concept. We're going to deal with this a lot in the future, but right now you just remember what I told you, okay? For a continuous variable, this is a continuous variable. Continuous variable. And then the graph of this probability distribution is going to look like a curve, and the shows the probability. Guess what? You can find what is the probability that the student height is between 48 and 65, which is this area. So right now we use area to show probability for continuous variable. Okay, so that's some new concept. You haven't learned how to do that yet. I just want to let you know. Then is this x a discrete or continuous? It is a continuous variable. All right, so I don't give the exact number here. I just want to let you know some concept. Number 3. If probability of a boy equals 1/2 and the probability of a girl equals 1/2. Is this a probability distribution? No. No, because x is not numerical. Their x right now is non-numerical. They're not numbers, so this is not. Okay, so this is not. I'll give you another one. I give you a formula, which is this. And here, x is 1 and 2 and 3 and 4 and 5. Is this a probability distribution? If it is, let's see, we're going to have x and a p of x, 1, 2, 3, 4, 4, 5. Okay, and the probability will be 1 over 1, 1 over 2, and 1 over 3, and 1 over 4, and 1 over 5. I don't have enough space, so I just write it like this. Is this a probability distribution? First one, x is numerical, and p of x shows the probability. Seems like the first one condition was good, right? Now the second one, all the probabilities add up to 1. The sum of all the probabilities, of course, is not 1. And then all the probabilities between 0 and 1 inclusive, that is okay. So the second condition, the sigma of p of x, which is a summation, this is called a summation notation, or we call this a sigma. Sigma of p of x is greater than 1. So this is, again, this is not a random variable. Okay. Let me do one more. We do the coin one. How about that? Okay. Do you remember you toss 2 coins and the x is the number of tail? I just changed that a little bit. Number of tails in 2 tosses. Here's x. X could be 0, could be 1, could be 2. How many tails? Right. And what is the probability of that? And do you remember this is a 0.25, this is a 0.5, and this is a 0.25. The probability to get 2 tails is 0.25. Probability to get 0 and 2, both 0.25. The probability to get 1 tail is 0.5. This is a probability distribution because this is x, 1, 0, 1, 2 numerical, good, and the p of x shows the probability, good, and then the all the probabilities add up to 1, right? And all the probabilities are between 0 and 1, inclusive, so that's right. Now, you know what I ask you to do? I ask you to find a mean and a standard deviation. Okay, so here is the formula. The mean is, see that x value times the probability, get the product, add up, you get a mu. So we have x, we have p of x. I only need, here's the sum is 1. I only need x times p of x. So which is 0 times 0.25, which is 0. And then 1 times 0.5, which is 0.5. And then 2 times 0.25. It's just the x value multiplied by its probability, so that's 0.5. We only need to add them up, which is 1, because 0 plus 0.5 plus 0.5, which is 1. What does that mean? That means our mu is 1. Okay? And then can you find the standard deviation? If you're looking for the standard deviation, you have to find the variance, right? And the variance is you use x minus mean. In our case, mu is 1. So x minus 1, you square it, and then you multiply by p of x. So let me do that. Okay. I will put in several columns, but you don't really need to. I do x minus mu and x minus mu square, and then x minus mu square times p of x. Okay, I just want to show you all the steps. Now, first one, we are going to find what is x minus mu. Mu is 1. X is, there's 3 numbers. So this number minus 1, I get a negative 1. And 1 minus 1, I get a 0. And then 2 minus 1, I have 1. And then I will square this column. This column is this guy square. So negative 1 square, I get a 1. 0 square is 0 square is a 0. And a 1 square is 1. Not done yet. I have to use the square term multiplied by the probability, which is here. So I'm going to, you see my fingers, I'm going to multiply these two columns. So 1 times 0.25, which is a 0.25. 0 times whatever is a 0. And the 1 times that is, again, is a 0.25. You add this up, you get a 0.5. What is that? That's your variance. That's 0.5. Okay? By definition, that's your variance. And then what is a sigma? Sigma is just the square root of it. So it's the square root of 0.5. The answer is 0.71. So we got the mean, we got the standard deviation. That's what you should do. Okay, now you might want to stop the video and then read this again and then think about it. So once you have the probability distribution, you have x, you have p of x, and you double checked that satisfy the three requirements of the probability distribution, then you can go ahead and find the mean and the standard deviation. And the way to find a mean is you use x multiplied by the probability. You get a new column, add up, you get a mean. In order to get a standard deviation, you really don't need these two. You don't really need these two columns. I just put them there. I just want to show you my work step by step, but you can do this directly. X minus mu, so that's x minus 1, which is a 0 minus 1. You do this in your heart, in your mind, okay? So it's a 0 minus 1, negative 1 square. You get a positive 1 times the p of x, which is 0.25. All right, so you do that, you get a variance, and you take the square root of variance, you get a standard deviation. Okay? It's not too bad, isn't it? All right, now we are going to think about one more. Give you one more example, I believe. Let me put example 5. Okay. When we talk about odds, you bet $5, okay, on number 7 in a roulette, and the probability of a win and the probability of loss. Okay, I give you this probability. So the probability of a loss is 37 over 38. It's really high. And the probability of a win is 1 over 38. And how much you're going to win? You're going to get 175. Okay? And what does that mean? So actually you get 180 back. But $5 is yours. Is your bet. You get the money back, okay? And then this is the net profit or net winning. Okay. And if you lose, how much you're going to lose? You're going to lose $5. All right. Now, let's make this to be x. X is your gain. That's the value of your winning. That could be just two possibilities, either negative 5 or positive 175. Okay, and what is the probability of to get negative 5, or what's the probability that you're going to lose 75? That's 37 over 38. And what is the probability that you're going to win 175, which is 1 over 38? All right, now check the requirements. X is numerical value, which is in dollars, and the P of X is the probability of it. Okay, requirement number 1, good. Requirement number 2, the probabilities add up to 1. Is that right? 37 over 38, 1 over 38 add up to 1, so we're happy. The third requirement is both probability values here are between 1 and 0, between 0 and 1. So we're good. So this is a probability distribution. Now, I ask you to find a mean. That's x times p of x. So that will be negative 5 times 37 over 38. Okay, and here it's going to be 175 times 1 over 38. Of course, you have your calculator, so you can get the answer. It's negative 4.87. Okay, and here this one is a positive 4.61. I think 4.61. Yes, it's H7. Okay. All right. So once you figure that out, you're going to add them up. If you add these two numbers up, negative 4.87 plus 4.61, the answer is negative 0.26. That's your mean. Okay. What does this mean? It probably will mean something to you, right? Okay, let me tell you that. The mu, in this case, in the probability, is also called expected value. Or some book use EV to show that expected value. That means if you repeat this for many times, at the end, the average will be this expected value, or the average will be your mean. All right, so if you go back to this one, the number of tails in 2 tosses, remember the mean is 1. Okay, you have 2 coins, toss it, write down how many tails in this procedure. Could be 0, could be 1, could be 2, right? Just write it down. Do it again. Do it again. Do it again and again. So if you toss the 2 coins again and again, you're going to write down a lot of numbers, right? All those numbers are either 0 or 1 or 2. Okay, let's say you do this for many times until you are really tired. And then you cannot stop, okay? You're tired, so you stop tossing the coin. Then you go back to look at all the numbers you write down. Find the average of it. Guess what? It's going to be 1. That's what it says. Okay, now here, this one means, this one, for you bet $5 on this roulette, on this number 7. If you do this many times, in the long run, your average loss for each game is 26 cents. That's what it says. Okay, so that's very interesting, right? Okay, are you interested in doing the standard deviation or variance for this one? You can go ahead and do it. You're going to use x minus mu, square it, and then times the probability. You're going to get 2 numbers, you add up, then you get a sigma square. Okay, you take the square root of it, you get a standard deviation. I'm not going to do that, but if you like, you can do it. I can't wait to tell you something further after we get a mu and we get a sigma. We get a mean and a standard deviation. There's something very important called mu minus 2 sigma and mu plus 2 sigma. This value is 2 standard. Here's the mu. All right, now you go up by 2 sigma. See, that's a sigma, that's a sigma. Here's mu plus 2 sigma. And if you go down, this value will be mu minus 2 sigma. So any value here and here, you shouldn't see them very often. Why? Do you remember we learned the empirical rule? Okay, if it's a bell-shaped distribution and we have 95% of the data fall within 2 standard deviations of the mean, See, that's the 2 standard deviations of the mean. We have, if it's a bell-shaped distribution, then we have 95% of the data. By Chebyshev's rule, if k equals 2, do you remember it's 1 minus 1 over k squared? When k equals 2, so 2 squared is 4, and 1/4 is 25%, so 1 minus that. We have 75% of the data for any distribution. We have at least 75% of the data fall within 2 standard deviation. So based on this, we know that we shouldn't see many numbers outside these 2 standard deviations, right? If a number you see is really big, it's greater than mu plus 2 sigma, we're going to call this value significantly high. And of course, this side, we're going to call all those values significantly low. Okay? All right. Now, use this one as our example. Remember the coin thing? The coin? We have mu is 1. We have sigma is 0.71. So the mu is 1. And then here's a 0.71, another 0.71. So mu plus 2 sigma, actually that's 1 plus 2 times 0.71. It has a numbers, right? It has a value. All right. So that would be, that's 1.4, so it's going to be 2.42. So here's 2.42. And the other side, mu minus that, so it's 1 minus 2 times 0.71. So it's 1 minus 1.42. So you're going to get negative 0.42. So that's negative 0.42. All right. Are you getting anything more than 2.42? Remember, those are the number of tails. Of course not, right? Because all the possible values you have is 0, 1, 2. So no matter how many times you do that, no matter how many times you toss your 2 fair coins, you're not going to see the significant high value, significant high number of tails, or significantly low number of tails. All right. But it might not be true for the other situations. So this one just want to tell you the general idea, and this is a super important thing. Once you know the mean and the standard deviation, at least you know most of the data fall within 2 standard deviation. That's what it says. Mu plus 2 sigma and mu minus a sigma. And I hope you can remember my little graph here. And then that will help you to determine whether a value from certain procedure is significantly high or significantly low. Okay, so that's all for the probability distribution. That's everything you should know for this.